Welcome to another tutorial of MATLAB Tech. In this particular tutorial, we are looking into the concept related to Autosar. In this particular video, we will be having a look into different layers of Autosar and how they work together. So what you will get by seeing this video is the main question over here. So we will go through the introduction of different layers of the Autosar, and then we will see what is the advantage of this layered concept in the Autosar, and then we will try to understand what is the topmost layer, which is the application layer in case of Autosar. Once we understand the use cases of the application layer, then we will jump into one scenario or an example where we can understand like how these things works together, these layers, with the help of development of a feature. And at the end, we will summarize everything and conclude what is basically this application layer is about and what are the different layers acting with this application layers. So coming to the Autosar architecture, you basically will see multiple layers of the Autosar architecture. So the first layer that you will be able to see is the application layer, where you will be writing all the advanced softwares. The features that you will be developing is in this layer. So we will see in detail what is basically application layer. So the next layer is Autosar runtime environment, which is basically called RTE. And this provides the interface between the base layer and the application layer. So here in this case, if you want to consider what is base layer, so in this case, whatever you are able to see below the RTE layer, which is the runtime environment, all are included in the base layer. And then you will have in the base layer, there are multiple components which are basically called layers, and you will have a service layer. So here you will have a service layer. So here mostly you will be dealing with all the diagnostic related things. Like suppose if you want to trigger a DTC, or if you want to trigger something in the vehicle. So all these things helps works with the diagnostic service. So that is provided with the service interface. And you will also have memory service and all those things, because definitely when you are dealing with software, you need to store the content in case needed in the EEPROM. So because of that, you need memory services. So all these things are included in the service layer. And then if you consider the ECU abstraction layer, which is the next layer for the base layer. So here you will have abstraction of the ECU, like you will have multiple functions over here, which is basically getting service from microcontroller abstraction layer. So microcontroller abstraction layer basically contains all the relevant functions which deals with the microcontroller that you are using inside this ECU. So this is the all detailed layer structure, and along with that you will have a complex driver. So basically why we need a complex driver layer, so you can see it is directly connected between the RTE layer and the microcontroller. So basically when you are trying to develop a Autosar based software, then it is not possible for everyone to develop the same framework because of some restrictions. So at that moment, suppose if you want to integrate your software inside the Autosar architecture, because your software will be with Autosar architecture, then it will be very difficult. Then how you will solve that problem? So to solve that problem, you can use this complex device driver part to integrate the non-Autosar compliant software to your Autosar compliant software. So this is a bridge between non-Autosar and Autosar. So that is why you need this complex device driver layer. Along with that, if you are dealing with some safety critical application, then in that case you need quick response from your system. So that is only possible when you have a shorter path. So it is directly connected to the application layer with the help of microcontroller and RTE layer. So the response time over here will be very quick. So that is what the complex device driver is meant for, but it does not means like whenever you need you can use that. So basically you need specific application which you can use over here, and that is why it is being developed. And over here if you see, we have two flow arrow. So first is the service flow. So if you see the lower layer, it will always provide service to the upper layer. So microcontroller abstraction layer will provide the service, its service to the ECU abstraction layer or to the service layer. So wherever you are able to see some connection, that connection means the layer will be able to provide some service to the other layer. So here the microcontroller abstraction layer will be able to provide the service to the ECU abstraction layer or give a service to the service layer as well. And microcontroller abstraction layer also can give service to the device driver as well. Okay. And if you see the ECU abstraction layer, so here ECU abstraction layer can provide service to the RTE layer or to the service layer or the complex device driver layer. And coming to the RTE, it provides service to the application layer, and that's how the communication happens. So service means some particular defined function calls. So you have defined functions and then you are calling it and you are getting some response. So that is basically called service in this case. And coming to the control flow, so how control flow works. So we seen like service flow works from downward to upward in case of Autosar architecture. But if you consider the control flow part, then the control flow from top to bottom. So basically from application layer to the microcontroller. So all these things we will see later in the videos. But this is some brief overview about the layers. And coming to the layers, what is basically these layers are. So if you see the actual software, these are not separated like boundaries, something like that. But a layer means software architecture referring to a logical group of software components. So suppose a software, a set of software is providing same type of characteristic, like a setup software providing only ECU abstraction related service, then you will be putting it inside the ECU abstraction service. If something is a group of function is doing the work for the microcontroller abstraction layer, then in that case you will be grouping them into this layer. So this is basically grouping, but not like discrete discretization between the functions, like you are able to see the boundary. In actual software you will not be able to see these boundaries. Then coming to the next point here, like hardware software independency, right? So if you make change software design, then there will be no dependency on the hardware change, right? So suppose I selected a microcontroller. Now what happens, I want to change my software features. So feature I will change in the application layer and remaining part will stay the same. So I can update my software anytime, and here there is a good amount of software that are dealing with these changes, so that you don't need to change your hardware, right? So because of that, this layer change or in the application layer change will not affect your change in the hardware, or it will not demand a change in the hardware. So because of that, it is totally safe to update anything on the application layer, and you can use it with the same hardware. And here, if you are seeing the layers, right? So why these are basically called layers? Because these are independent components, and clear interface will be there for that. Like suppose you have defined this service layer, right? So that will have clear interfaces. Like interface means inputs that you can provide. So that will have clear interfaces through which you can give input to that layer and get something. So these layers are independent, and that's why it is very easy for you to modify any component inside this layer without affecting the other layers. Okay, that is this independent part. And coming to the microcontroller, so these layers are basically which you are able to see below, right? In the base layer. So they are basically meant to abstract the feature of the microcontroller with the help of some functions. So that it can provide service to the upper layer. So we see in this service flow, right? So if something is requested to the microcontroller abstraction layer, then it will talk to the microcontroller, and it will have some functions that can be provided to the upper layer, which is basically the ECU abstraction layer. So this is basically the overview for the different layers of the Autosar architecture. And coming to the application layer, so we have the application layer on top, and what basically application layer is being used for. So suppose you have a vehicle and it has a great dashboard, and in that you can see many things, right? The speed of the vehicle, at what speed it is going on, the RPM of the wheels, and basically time and date and all those things, whether the vehicle is in neutral or gear, or whether the fuel is completely filled, or it is like you can see the fuel level as well, right? So these are the things that are basically done on the application layer. So some of the example could be like a vehicle dashboard showing these features, like cruise control system. So you can see your vehicle, how far it is from the front vehicle, and if you want to maintain a defined distance, then you can achieve it with the help of this cruise control system, right? Then current speed at which the vehicle is running, you can see this, and this is done with the help of this application layer only. And running anti-lock braking system. So suppose you are running and controlling the anti-lock braking system, then that can be done with the help of some algorithm. So you will be detecting the slip, like how much the vehicle tires are being slipped, and based on that you will apply the brake. That is done with the help of some sensing and some actuation. So that is done with the help of some algorithm, and that algorithm can run on the application layer for that particular ECU. And you can also display the current vehicle status, like whether it is in the park, neutral, and all those things. So that can be displayed, and these all things can be developed inside a application layer. So what basically application layer contains? It can access the so basically what you whatever the logic that you develop, right, inside this application layer. So it basically uses the resources of the hardware that are available through some services, so that you can get some service like cruise control system, lane assistance system, or lane departure system. So all these things you can get through the hardware, but the logic you need to build on the application layer. And it implements the high level behavior. So whatever you are able to visualize, right, so those things it is able to implement. So as you can correlate it to a automatic driving assistance system or a battery management system, so these you are able to see. But whatever is happening on the back end in the hardware, so that is being handled with the base layer. So high level implementations are done in the application layer. And then the layer that contains like this layer contains a chain of algorithms. It is like these algorithms, maybe you can call it as software components, and individual software components will interact with each other to develop a chain of algorithms. So the chain of algorithms is possible to create in the application layer. So basically, when you are dealing with algorithms, if you are dealing in future or currently dealing with, then that is you are dealing with the application layer, not with the service layer or ECU abstraction layer or microcontroller layer or the complex device driver layer, right? So this is the application layer. So now what we will see a use case. So how these things works together to develop this particular system in the application layer, how the application layer gets the information, how it acts and how it behaves, and how the control flow and service flow works. So now we will be taking the example of blind spot detection. So that happens most of the time with the help of a radar sensor, and you need a radar sensor to do all these implementation and the logic you will be developing in the application layer. So in this particular scenario, we will be implementing this blind spot detection algorithm, and how this algorithm works, that we will be having a look in detail. So suppose you have a radar sensor over here and that is detecting objects, and basically when it detects some object, it sends some signal to the ECU. Once the ECU receives this, it will go to the microcontroller. The microcontroller service will go through this microcontroller abstraction layer to the ECU abstraction layer. And from the ECU abstraction layer, the port which is responsible for reading the data from the sensor is being assigned in the RTE layer, and the signal goes to the application layer to the first software component, that is the reading of the radar data from the sensor. So basically the sensor data is being read in this particular software component. So this is the first software component that is present in the application layer for this particular use case. And once this radar data is being processed, because in this case basically you will have a lot of noise or you will have a lot of interference that will be detected in this data, because this will be raw data. So because of this, you need to process that radar signal and send it back to the same RTE port to a different port. So we will see like how this RTE interface works in later on, but basically it sends it to the RTE. So once it is sent to the RTE, the next step is track the object. So now you have the data, now you will be tracking the object. So once you do track the object, then you will classify, right? Track the object and classify. This is happening in a different software component. And once you classify, so there could be two states in this case. One is hazardous state and another is non-hazardous state. So in hazardous state, you will have chance of accident. In non-hazardous state, it is totally safe. There is no object in the blind spot, which it means. So based on this classification, what basically will happen, the processing of hazard potential will be taken. So with the help of the process the data, detect the potential hazard software component. Okay, so once this is being processed and it is detected that there is a hazard that is present inside the blind spot, then in that case there will be a signal sent again back to the RTE, and RTE will update the relevant signal, which is generating the relevant audio visual output, right? So here in the audio visual output algorithm, so what it will do, it will try to generate all the relevant components or the signal values that are needed for generating the audio visual signal. Then it will be communicated to the RTE layer, and post to that it will be communicated to the ECU abstraction layer, and then it will be communicated to the microcontroller abstraction layer, and through the microcontroller it will go to the audio visual device, and then it will activate the alarm. So here we've seen two flows. One is the service flow that the first software component is receiving in this case, and another is the control flow. So that is generated from the last software component. So this is the entire process through which everything is being processed for the blind spot detection algorithm, and that is how it is working with the application layer. So if you do any change in these algorithms right on the top, then there will be no impact because the radars will be there already, and to run the radars, the driver will be already present, and to send out the audio visual signals, the device will be also there, and the the basic software to trigger that action is also present in the base layer. So there is no issue if you change anything on the signal generation or in any of the algorithm that is present on the top, right? Only thing is it should work as per the request from the requirement, right? So all these are developed based on the requirements. So till now, what we've seen is different layers of the Autosar architecture, how these things works. And we also seen the application layer and what can be done with the help of application layer. And we seen a use case for the blind spot detection. And yeah, this is all about the application layer. And in the coming video, we will be looking into RTE layer and also regarding the concept of virtual bus and how the Autosar architecture is being defined with the help of virtual bus. So we will see that concept next, and later on we will discover all the details of these layers that we have not yet done. Along with that, we will also do a deep dive for the application layer, and we will try to see like how more detail these things works. So in case you are liking the channel, please consider subscribing. In case you have any comment or query, please let us know in the comment section. We will be more than happy to clarify your doubts. Have a great day ahead. Thank you. Take care.